In this YouTube video, I continue to give more techniques and tips on how to solve IB chemistry questions in paper 1. In this YouTube video, I am dealing with atoms and moles.
Some students have difficulty with these two questions. The important words in each question are, in this one, atoms and mole, and here, atoms and molecule. When it comes to atoms in a mole, then you must remember they are based around this number 6.0 times 10 to the 23, and therefore any answer will be a large number, something of the order of 10 to the 22, 10 to the 23, or 10 to the 24. They can be larger still or smaller, but in general, in paper 1, the answers will be of this order. In this question, when we're referring to atoms in a molecule, the numbers are small. They're of the order of 1, 2, 3, maybe up to 12. So let's go through these calculations involved. When you're dealing with atoms in a mole, the first number to write down is this number, 6.0 times 10 to the 23, and then look at the number of hydrogen atoms in this molecule. And the number of hydrogen atoms in this molecule is 7, so you multiply that by 7, and then you look at the number of moles. The number of moles is 1, so you multiply that by 1, and that equals 42 times 10 to the 23, which equals 4.2 times 10 to the 24. Okay, which means that that is the number. You should ignore that number because that is clearly not a possible number. The other two were possible, but that is clearly not a possible number. In practice, you would have ignored this number as well, because you know that that applies to one hydrogen atom in 1 mole. And you know you've got more than one hydrogen atom in 1 mole, so that one would have been out. So it would be a choice between those two, and the calculation shows it's that one. Now when you go to this question, you know you're looking for a small number. You can immediately do that without even knowing the formula of carbon dioxide, but you do know the formula of carbon dioxide. It's CO2, and there are 2 oxygen atoms there. Now you may say, well, what if they give something like cholesterol? Now cholesterol has a formula C27H46O. And yes, they could ask how many carbon atoms in 1 molecule of cholesterol, and you would say 27. How many hydrogen atoms in 1 molecule of cholesterol, and you would say 46. But in my experience for both of these questions, they tend to give small molecules, CO2, CH3OH, C2H5OH. That one I've seen a few times, C6H5CONH2, and of course propanone. They love propanone. So most of this kind of question on these molecules would give an answer which is small number, less than 12, small number. Okay, in that question it gives a number of 10 to the 22, 10 to the 23, 10 to the 24, depending on the specifics of what they're asking. The important thing about these kind of questions is read the question. Atoms, mole, gives you a large number. Atoms, molecule, gives you a small number. When you look at this question, you're looking at the word atoms and mole. And therefore we're dealing with a large number. We're starting with 6.0 times 10 to the 23. If necessary, write it down. You could ignore that one because you know that's just too small. What you then do is it says the total number of atoms in 0.2 of a mole. So we multiply that by 0.2 because it's not 1 mole, it's 0.2 times 6 times 10 to the 23. And the total number of atoms in this molecule is 10, so that comes to that. And that equals 1.2 times 10 to the 24. There are different ways of getting it, however you do it, but you're not using a calculator, you're just writing it down. And your intermediate may be 12 times 10 to the 23. If you write it down, then you get 1.2 times 10 to the 24. And that gives you C. This is an interesting question, however, it does cause problems for some students. Let's see, the question asks for ions in this fraction of a mole. So we know we're going to start with the base number 6.0 times 10 to the 23 when we do the calculation. However, before we do the calculation, let's see if we can eliminate some of these answers as unlikely or impossible. First of all, we're asked for the number of ions in this fraction of a mole. It can't possibly be a number like that with a negative power. That's simply too small, so that's out. It can't possibly be this one. That's also a negative power. That's simply too small. Look at this one, 6.0 times 10 to the 23. That's our basic number for ions or molecules in a mole. So it's unlikely to be that one. This only leaves the last one, D. Even though we haven't calculated, not quite sure how to get to that number, that is the only one that makes sense. Now let's do the calculation. 6.0 times 10 to the 23, we start with that. We then go to this volume here, that's 50, and we divide that by 1,000 because whenever we're dealing with these kind of things, we need the fraction of the decimeter cubed that we're talking about. This is 50 centimeters cubed, and that's 1,000, and that is the fraction of the decimeter that we're dealing with. And this is also a fraction of a decimeter, so you put the 0.1 in as well. And then we look at the sodium hydroxide. We're asked for ions in sodium hydroxide solution. Well, for every sodium hydroxide there are 2 ions, the sodium ions and the hydroxide ions, so we multiply by 2. Okay, so even though it's 0.1 mole of sodium hydroxide solution, there are 0.1 times 2 moles of ions in that solution. So this is the basic number we're working with, and you do not have a calculator, so you have to do this on paper or in your head. And for some it's difficult, for some it's easy. Let's get rid of that, and let's notice that those 2 we can get rid there and make it 21. So it's 6.0 times 10 to the 21 times 5 times 0.1 times 2. And we can do this. Let's bring the 6 times 5 is 30, that's 30, times 0.1 is 3, times 2 is 6. 6 times 10 to the 21. And that comes to that. Now you may have had a different way of doing this calculation, but you have to be able to do this kind of calculation on paper without a calculator. Make sure you can do it. And as I showed you before, it fits in with the method of eliminating impossible numbers. I encourage you to look at the answers to these questions and see if any can be eliminated because they don't make sense, they don't fit. However, there is no guarantee that all 3 can be eliminated by inspection. Sometimes you have to do a calculation. So while you're practicing, practice elimination of incorrect answers, because that helps you understand the process better. And secondly, do the calculation, because at the end of the day you may have to do the calculation in the exam for paper 1, and certainly if this type of question comes up in paper 2, you will have to do the calculation there. This is an interesting question because you are asked to find how many molecules are in a mole of molecules, but it's not a mole, it's a very small fraction of a mole. So the number is still based around 10 to the 23. However, you must realize that you're probably not going to get the same numbers as I suggested earlier, 10 to the 22, 10 to the 23, 10 to the 24. And that is why this one is a very unusual one. And it is rare, but it has happened. It has come up. This question has come up, and therefore you have to deal with it. I'll do the calculation first. We start off with the basic number 6.0 times 10 to the 23. We multiply it by the fraction of the mole, which is times 2 times 10 to the minus 21. And then we look at the rest of it. They're not asking you for any parts of a molecule, atoms in the molecule or anything. They're asking you for the total molecules. How many molecules does this represent? So that is the answer. Now this represents a mathematical issue for some people. You have to multiply the two numbers together, 12.0, and then you add, or subtract in that case, the powers. So it's 10 times 10 to the 23 minus 21, which is 2. And that equals 1.2 times 10 to the 3, which is this one. Having done that calculation, we can now look at the answers, and we could have initially eliminated this one, because no way is it going to be a fraction of a molecule, 10 to the minus 21 of a molecule. So that is out. It could not possibly be that. Secondly, we could look at this one, and it says 6 times 10 to the 23. That's the base number. We know it could not possibly be that, because we are using a very small fraction of a mole. So it couldn't be that. And it couldn't be this, because this is millions and millions and millions greater than this number. So that one's out, that one's out, and that one's out. We could have done this simply by looking at it and without doing the calculation. However, in this case, the calculation was straightforward. Thank you.
Thank you for watching. If you found this YouTube video helpful, please look at my other videos as well. Thank you.